Alright, so today I just wanted to talk to you a little bit about my new project. I'm going to try and design my own Nixie watch. This is essentially going to be just like a digital watch, except for the display I'm going to use vintage Nixie tubes as opposed to the more modern LED and LCD displays. I want to make it kind of smart as well, so I'll try and add things like gesture recognition, wireless charging, capacitive touch buttons, and also the ability to display things like temperature and date as well. I'm also considering Bluetooth so that I could maybe develop a companion Android app for setting up the watch. These are all just ideas at the moment, and it'll probably come down to how many components I can physically fit on a tiny little PCB and still have space for the Nixie tubes. So why a Nixie watch? Well, for me personally, I've always loved Nixie tubes. There's just something about them, right? They have that kind of vintage look, but at the same time, they also look kind of futuristic as well. But honestly, this project isn't necessarily about what I'm making, but it's more about the skills and the knowledge I'm going to gain trying to build this. I'm going to design this thing from the ground up, so that includes PCB design, case design, and also development of the firmware that will run on the watch. There's a lot of design challenges here, mainly creating a power efficient device that can be scaled down on a really small form factor so that it would look pretty good on your wrist. Also, I really just like the idea of designing and building a one-of-a-kind wearable that I can actually use every single day. So I've already done some preliminary work for this project. The first thing I started playing around with was PCB design. So following last week's video, you'll know that I like using STM32 microprocessors on my projects. That being said, I've never actually designed a custom PCB for an STM32 chip. So that was my first move here. I just wanted to see if I could design a custom PCB for an STM32 chip, install all the components, and be able to flash code to the chip successfully. If this were to work, I'd then be confident in my own schematics, and I'd be able to go ahead and design a really small PCB for the actual Nixie watch. So after trawling through a whole bunch of schematics and datasheets, I actually did manage to design my own PCB using KiCad. I had the board manufactured and I installed all the components myself. Surprisingly, this went pretty smoothly. I did make one tiny mistake which I fixed with some patch wire, but other than that, it was a success. I'm able to power up the board and it's running my code which flashes that little blue LED. I know a lot of you are going to be interested in how I designed that board, so I will make a separate video about that where I kind of talk you through the schematics and some of the more important points that you need to consider when designing the PCB. The next thing I wanted to do was actually start playing around and testing these Nixie tubes. These are z5900m Nixie tubes. They're vintage and actually pretty difficult to find. These smaller tubes tend to be the rarest and most expensive, but if you're designing something like a Nixie watch, you need them to be really small, so they're pretty much your only option. For those of you that are interested, I will also be dedicating a separate video to Nixie tubes. I'll talk about how they work and how you can use them in your own projects. But for now, all you need to know is that to power these tubes, you need a 200 volt power supply. So I had a little look online and I found a voltage booster schematic that's actually designed specifically for Nixie tubes, and I'll link this down in the description below. I've created that same schematic in KiCad and I've tweaked a few of the values to suit my project. So first of all, I breadboarded the circuit just to see if everything worked and to also play around with some inductor and resistor values. When I was happy with the voltage output, I transferred the design over to a copper board. I think this actually turned out to be a neat little circuit, and I'll definitely be using this in the future to test Nixie tubes. Obviously, when I design the actual watch, all of this is going to have to be shrunk right down so that it can fit onto a very small PCB. This can be done using surface mount components, as opposed to the through-hole ones that you see in this prototype. Okay, so let's take a look at our input and output voltage using the multimeter. You can see that at the input terminal we have 12 volts and at the output terminal we have 200 volts. And this circuit operates at around 80% efficiency, which isn't too bad. Typically with Nixie tubes, there's an ignition voltage in order to turn it on, which is usually around 200 volts. After the ignition, the output voltage drops, and this is called a sustain voltage. The positive terminal of our output should always connect to the anode of a Nixie tube. You can find out which pin is the anode by looking at the datasheet. Then, to select which number we want to illuminate, we just pull that pin down to ground. Again, the datasheets have all the information about the pin numbers and which numbers they display. So you can see here that I can switch between different numbers just by grounding different pins. And in the final system, where we have 2 or 4 of these Nixie tubes, what I'll use is a high voltage shift register. This will allow me to use the SPI communication protocol on a microcontroller so that I can display whichever number I want. These tubes also have a decimal point either side of the number, but I'm not going to use these, so I'm just going to leave them. I did also buy other Nixie tubes. These were made brand new in Ukraine, and I'm going to be using these for all my testing. This is mainly because I don't want to wear out the vintage Nixie tubes any more than I have to. They were expensive, and also if something goes wrong, I don't want to break them. As with any other electronic component, Nixie tubes do have a lifespan, so I'm going to keep those vintage tubes for the final watch design. The pins on the 2 different tubes are slightly different, but I can accommodate for that in my PCB design. I also have these other VFD tubes which just illuminate in a nice kind of green or blue colour, and it looks really good. If there's room, I'm going to add 1 or 2 of these to the watch because I think it's a nice touch. You can see here, this is my Apple Watch and it's quite small, and the tubes in comparison are still pretty large. It's likely that I'll use 2 Nixie tubes, but I'm really going to try my best to squeeze in 4 if I can, just because I think it looks a lot better. I guess ultimately it'll come down to how big I want the watch to be. So that's basically what I've been up to for the past couple of weeks. I'm making good progress and learning a lot, especially around PCB design. I'm really looking forward to the rest of the project, especially when we get to the CAD stuff, where I have to bring all this stuff together to create a real usable device. If you've got any cool ideas or suggestions for the project, please feel free to leave them down in the comments below. As always, thank you for watching. I hope you learned something, and I'll see you in the next video.